another technique to determine the interpolation polynomial called the divided differences or Newton's divided difference polynomial, NDDP. So what's a Newton's divided difference polynomial? Given n plus 1 points, so here again, n plus 1 points, x0, xn, with their output, the interpolation polynomial degree n called Pn. We can, as a polynomial of degree n, we can express it in this form. So this is the form. Instead قلنا احنا ممكن نكتبه Lagrange y0 L0 plus y1 L1 plus yn Ln, or we can write it also in this way: b0 constant plus b1 x minus x0 plus b2 x minus x0, we add another term x minus x1 plus b3 x minus x0 x minus x1 x minus x2 so on حتى نضربهم كلهم حتى ال xn minus 1 only. Be careful here. Then x minus xn doesn't appear. Okay, then نضرب في x minus xn also راح يكون polynomial degree n plus 1. X minus xn appears in the error, in the remainder. Okay, so here we stop at for the product as n minus 1. Each term we add a new, we multiply by a new linear polynomial x minus xk plus 1. Using this expression of the polynomial, it's another way to calculate the polynomial. The question is, what are these constants b0, b1, b2, and bn? This is what we call divided differences. هم divided differences. وهذا, this way of writing the interpolation polynomial is called the NDDP. Okay, so what are these constants? To find them, we start always by the easy case, the linear polynomial. So the linear polynomial will have only b0 and b1 times x minus x0. And just we say that p1 of x0 اللي هي y0 will be b0 plus b1 x0 minus x0. هذه 0 يعني هذا كله 0. So البي 0 راح يكون f of x0. This is b0. b1 شو راح يكون؟ p1 of x1 اللي هي f of x1 راح تكون b0 يعني f of x0 plus b1 x minus x0. So b1 is nothing else than the divided difference. This is why we call it divided difference. We have difference and division. This is b1. This is a divided difference. This is the idea. We can move to the quadratic degree 2, and we can show that b0 is always f of x0, that b1 is the divided difference fx1 minus fx0 over x1 minus x0, and that b2 has this expression. So it's easy to code on computers. Since this is the order 0 will be f of x0, the divided difference of order 0 at x0. This will be the order 1, the divided difference of order 1. This implies, this involves x0 and x1. It's order 1. It involves 2 points. And here we can say that b2 هذا هو هذا. So minus fx0 x1. وهذا يشبه لهذا لكن involve x2 x1. So هذا f x1 x2 divided by x2 minus x0, and this will be the divided difference of order 2. So you will see that the implementation is very easy here. Okay, so here fx0, x1, x2, we have 3 points involved. So this is the order 0, 1 point involved, order 1, 2 points involved, order 2, 3 points involved. But to find the order 2, we need all divided difference of order 1. Not only this one, but this one and this one. Okay, so in practice, these are the divided differences. So how to calculate this? For the order 0, it's easy, just the output for all the points. For order 1, taking these 2 points, we'll use these 2 values. So the difference in this way, backward, fx1 minus fx0 over x1 minus x0. To calculate this, we make this divided difference, fx2 minus fx1 over x2 minus x1. To calculate this, we make this difference, fx3 minus fx2 over the difference of the input, and so on. For the second division involving 0, x1, x2, we take the difference of these 2 values and divide it by the difference of the endpoints. For these 2, just the difference of these 2 values divided by the difference of the endpoints, and so on. اوكي، ونكمل من هنا. هذول الاثنين شو راح يعطيوني order 3 involving x0, involving x1, involving x2, and involving x3, and it will be the difference between these 2 values over x3 minus x0. هذه هي الفكرة. خلينا نشوفها على مثال. Complete the divided difference table and construct the interpolating polynomial uses all this data. Okay, so أعطانا الأوردر 0. مطلوب منا first order 1. هنا 5 points. لازم نوصل حتى الأوردر 4. For the order 1, with these 2, we can calculate f x0 x1. كيف نحسبها؟ هي this value 0.6200.860 minus this value divided by x1 1.3 minus x0 minus 1.
This is for order 1, right?
Sorry, order 1 first one لأنه لسه عندنا هذه أيضا order 1 involving x1 و x2 وعندنا هذه involving x2 x3 وعندنا هذه involving x3 و x4. We have to complete the whole table. هذا order 1. Then هذه نحسبها. This is the result. هذه كيف نحسبها؟ The difference of these 2 values 0.44554022 minus هذه 6200860 over x2 1.6 minus x1 1.3 ونحسبها. هذه راح ناخذ these 2 values. اوكي، دي الفكرة easy. Then 2818186 minus 4554022 over 1.9 minus 1.6. We calculate all of that. So we obtain, so this is f x0 x1 minus 048 تعال. minus 048 هذه x1 x2 I do the calculation for you. هذه x1 x2 هذه x2 x3 هذا order 2 order 1 نمشي الحين order 2 involving 3 points. إذا من هذا من الاثنين نجيب f x0 و x1 و x2. كيف جيت minus 1 0 8 هذه؟ نحسب the difference اللي هي minus 0 5 4 8 9 4 6 0 minus هذه minus 0 4 8 3 7 0 5 7 divided by x2 minus x0 1.6 minus 1. Then هذه هي. And you calculate this, or the computer calculate this, and you obtain this value. بعدين ايش نحسب؟ هل ممكن نمر الاوردر 3؟ هل ممكن نجيب هذه؟
لا، لازم نجيب اوردر 2 كامل.
نجيب هذه، لازم نحتاج هذه ايضا. هذه المشكلة. فلازم نحتاج هذه اللي هي x1 x2 x3. وبهذا من الاثنين ممكن نجيب الاوردر 3 اللي هي minus 0 0 minus 0 499 minus هذه على x3 minus x0 now. x3 minus x0 ونحسب. Okay, and this is the last value involving all points. حتى كتابة من x0 ل x4 you are done, you stop. Okay, so you have to fill in the whole table to be able to calculate the polynomial using this NDPP, Newton divided difference polynomial, NDDP. What will be this polynomial using this technique?
ممكن هذه نوعية الأسئلة تجي في المدة إن
يجي ما تيجي، كل اللي درسته راح يجي على كل جزئية خذ. فالان دي دي بي هذه شو راح تكون؟ لأن the polynomial هنا P4. في البولينوميال we take only the first row. It will be F0. So 0 7 6 5 1 9 7 7. F0 مش X. بعدين minus هذه 4 8 3 7 0 5 7 x minus x0 so x minus 1 وهذه minus 0 1 0 8 7 3 3 9 x minus 1 times x minus the second point اللي هو 1.3 plus 0 0 6 5 8 7 8 4 x minus 1 x minus 3 نزيد 1 the next point 1.6 and the last هذه 0 0 0 1 8 2 5 1 x minus 1 x minus 1 over 3 x minus 1.6 x minus 1.9 and we are done. قلنا هذا ما يظهر في الفورمولا. Okay, so this is another way to determine the Lagrange interpolation of polynomial. So this is P4. We will study a special case. Special case for NDDP. What is the special case? When the nodes, when the points xi's are equally spaced, which means that the distance between two consecutive points is constant h, like in the previous example. So here, this is x0, this is x1, this is x2, this is x3, x4. So if we do x1 minus x0 شتعطينا? What is the difference here?
0.3.
0.3. x2 minus x1 بكم?
0.3.
x3 minus x2 0.3. x4 minus x3 0.3. So here these points or nodes are equally spaced. And the difference between two consecutive nodes, xk plus 1 minus xk, is h, and h in this example is 0.3. So this is the meaning of h, the distance between two successive points. So to apply this formula, we'll use this representation of any point x, which is x is not a node, not a given node, not a given point. A given point or node. So x, so here you have your nodes, x0, x1, x2, x3. So this distance is h, this distance is h, this distance is h, but x can be any point here. This is x. So here, this is distance will be represented by this formula, x0 plus sh. So x0 given, h given, s is variable. Let's vary because x vary. Okay? So the difference between x and any node is given by this formula, s minus I h. Okay? So this is important to know. And this, in this case, we can rewrite the NDDP polynomial in this way. So this is a new formula for the special case of equal spacing points in a forward way. In a forward way, started from x0, in a forward way. We'll see other ways. We'll see why we have other ways also. So, forward difference, we always start with x0, the smallest point. And this is the formula. The formula ايش كانت؟ كانت Pn كانت fx0 plus the first order x0, x1, x minus x0. The x minus x0 now is sh plus the order 2 x0, x1, x2, x minus x0 قلنا sh و x minus x1 تصير s minus 1 h. إذا هذه تعطينا s times s minus 1 times h square. هذه تعطينا اللي بعدها s times s minus 1 times s minus 2 h cube. And so on. S times s minus 1, s minus 2, s minus 3, h4. So here we replace x minus x0 by sh. X minus x1 by s minus 1h. And we obtain a new formula in this special case, easiest formula, okay, in implementation, to implement. This is called the forward difference. The forward difference. Why we need this? When do we need this? We need this when we want to approximate the value of f at a point which is close to x0. So here are our points. If I want to calculate f1.1, for example, this is closest to x0, so we use forward difference. Okay? This gives me the best approximation. Okay? We'll see later today that, for example, if I want to calculate f2.1, 2.1 is closest to x4. Okay? So here we'll not use forward difference, we'll use what we call the backward difference. Okay? We concentrate our effort here, close to x4. If I have some points here, 1.5, I will use what we call a centered difference, close to x2. Okay, this is the idea. Okay, to optimize the quality of our approximation. This is the idea. So, for the backward difference, if I want f2.1 and the points are still equally spacing, we'll focus on xn. We'll use this representation. هذه وين؟ في الباكورد. في الفورورد I recall استعملنا x0 plus sh. So x is x0 plus sh. هذه forward difference. Backward difference xn plus sh. And in this case, I will have another formula here. We'll use the differences with respect to xn. مو x0 like here. Okay? Then راح نشوف هنا we'll use these values في الفورورد في الباكورد we'll use these values. The idea, I repeat, to obtain a better approximation. Okay? Depending on our needs. So the formula راح تصير the differences with respect to xn. Another difference here, s times s minus 1 صارت s times s plus 1. s times s minus 1 s minus 2 صارت s times s plus 1 s plus 2. اوكي؟ خلينا نشوف مثال. نرجع للمثال اللي حليناه اللي حسبنا divided differences. Divided differences. هذا already calculated. If I need a forward, I will use these values. The differences اللي فيهم x0, fx0, fx0, x1, fx0, x1, x2, and so on. Okay? So here, our polynomial, this is the formula. If I replace P4 راح يكون fx0 then 0.7651977 plus s, it's my variable, h is 0.3, fx0 x1 here this value minus 0.837057 plus s times s minus 1 order 2 اللي هو هذا times minus 0.10873339 plus s و h ما ننسى h square هنا h square plus s minus 1 s minus 2 h cube times this value. 0.0658784 plus s minus 1, s minus 2, s minus 3, h to the power 4 times this value. 0.0018251. Okay, this is the expression. If now I want P4 of 1.1 لازمني نجيب الاس. شو العلاقة بين الاكس والاس؟ اكس هي، ارجع للقانون، x0 plus sh. So if x is 1.1, x0 is 1, h is 0.3, ونحسب ال corresponding s. It will be 0.1 over 0.3, so 1 over 3. Okay, so this is the value of s, and I replace here s by 1.3, and this gives me the value of P4 of 1.1. So I use this formula, I calculate s, I calculate h, and I have the first row in this table, the first diagonal هي تعطيني the divided difference اللي لازم نستعمل. توضح أكثر إذا نشوفوا backward difference we'll understand. Okay. إذا هذه شو؟ هذه هي x0 plus sh. هذه هي x. هذه s. هذه h. هذه s minus 1 h square. s minus 1 s minus 2 h cube. s minus 1 s minus 2 s minus 3 h4. وهذم divided differences f x0 حتى x4. هذه f x0 حتى x3. هذه x0 x1 x2. هذه x0 x1. هذه x0. This is how we obtain the NDDP using forward difference in this case. For the backward, we not use these values, we'll use these values in the back. Okay, so for the backward, to approximate, for example, P4 of 2.0 قريبة من x4, we'll use this formula backward. Okay, so you see here, we use this value, fx4. We'll use here this value, fx3, x4. We'll use this value, fx2, x3, x4. Okay, we focus here close to our point of interest x. هذه h square, هذه h4, h cube, h, and here what is the value of s? Again, we have to find s, x, here xn this time plus sh. Backward. Okay, backward. So x is 2, xn is 2.2, s, h is 0.3. So we calculate, نجيب هذه من هنا. So s is 0.2 over minus, minus over 0.3. So s is minus 2 over 3. Then for backward, s is negative. This is the value of s. This is the value of s. Okay, this is s. This is s plus 1. This is s. This is s plus 1. This is s plus 2. And so on. So this is the idea of backward difference when our point of interest x here is not one of the nodes. It's the point where we don't know the output and we want to calculate an approximate value using the interpolation polynomial. And here it's better to focus close to the point, so to use backward.